Hello everyone, in this video we're going to explore topic 5.5 using the candidate test to determine absolute or global extrema. Now, finding absolute extrema on a closed interval. Step number 1, find the critical numbers of f in the open interval a and b. Step number 2, evaluate f at its critical number in the open interval. Step number 3, evaluate f at each endpoint of the closed interval a and b. Note that these two steps are referred to as the candidate test. Now, step number 4, make a conclusion. The list of these f values is the absolute minimum or global minimum. The greatest is the absolute or global maximum. Right? Note that the actual maximum or minimum value is y value, where the maximum or minimum occurs would be an s value. Right? Now, example number 1. Find the absolute extrema on a closed interval. Question A. Find the absolute extrema of the function f of x equals 3s to the 4 minus 4s cubed on the interval -1 to 2. So first, you need to find the first derivative, right? It's going to be 12s cubed minus 12s squared. And then you need to find critical numbers by letting f prime of s equals 0, right? So it turns out to be 12s cubed minus 12s squared equals 0. Factor 12s squared out. It's going to be s minus 1 equals 0. And then you have s equals 0. This one is multiplicity of 2, right? And s equals 1. We're going to step the table. Alright, now you need to place the values of this interval on the table, right? So it can be -1 and 2, right? Then the critical numbers right here, 0 and 1, right? So 0, 1. Alright, f of -1, substitute -1 for s into this function right here. It turns out to be 7, right? Substitute 0 for s back into this function right here. It's going to be 0. Substitute 1, it turns out to be -1. And substitute 2, it turns out to be 16, right? Now, we look at this one right here. Step number 4. The list of these f values is the absolute minimum. And the greatest is the absolute maximum, right? So you just conclude that the function f of s has an absolute maximum of 16 at s equals 2 and absolute minimum of -1 at s equals 1. We're going to use the calculator to check our work, right? Bring up the calculator and graphs right here. Input the function, right? Then hit enter. It's going to be right here. Now you need to restrict the domain to -1 and 2, right? So you're going to hit menu, Windows settings right here. Should be -1 and 2 for s value. And hit enter. It's going to be right here. Alright, so now you need to hit menu, analyze graph, minimum, right? You have the absolute minimum right here, the lowest one, right? Hit enter, go to right, hit enter, the answer right here, -1, which is right here, right? Let's move on to question B. Find the extrema of this function on the closed interval -1 and 3. Now you do exactly the same thing, right? You need to find f prime of s. It's going to be 2 minus 3 times 2/3 is going to be 2. S power 2/3 subtract 1 is going to be -1/3. So this guy turns out to be 2 minus 2 over cube root of s, right? Now, let f prime of s equal 0. So that you're going to find the critical number, right? So this guy turns out to be, it's going to be 2 over cube root of s equals 2, right? Then cube root of s equals 2 divided by 2 is going to be 1, right? And you're going to cube both sides, so it turns out to be s equals 1, right? Numbers occur when f prime of s is equal to 0 or undefined, right? So you need to write f prime of s is undefined when s equal 0, right? Look at this one right here. S equal 0, f prime of s is undefined, right? So you need to conclude that the candidate should be 0, 1, and negative 1 and 3, right? Now you're gonna sketch the table. Now you substitute negative 1 for s back to the original function. It's gonna be right here. 2 times negative 1 minus 3 times negative 1 power 2 third. It's going to be negative 2 minus 3 is going to be negative 5. So the answer right here should be negative 5. Now s equal 0 is going to be 0. S equal 1 is going to be negative 1. And s equal 3 is going to be 2 times 3 equals 6 minus 3 cube root of 3 square is going to be 9, right? So you have 6 minus 3 cube root of 9. Now if you use a calculator to check, this guy right here must be less than 0, right? So then you need to conclude that f(s) has an absolute maximum of 0 at s equals 0, right? And an absolute minimum of negative 5 at s equals negative 1, right? Now you can use the calculator to check your work, right? So you need to hit Ctrl I, add graphs, input the function right here, 2s minus 3 times s to the 2/3. Hit enter, it's gonna be right here. Now you need to restrict the domain, right, from negative 1 to 3. So you need to hit menu, window setting right here, negative 1, 3. Hit enter, it's gonna be right here. Alright, so absolute maximum is 0 at s equals 0, right? And absolute minimum is on the left hand side right here, negative 5 right here at s equals negative 1, right? Now let's move on to question C. Find the extrema of f(s) equals 2 sin s minus cosine 2s on this interval, right? So you need to take the first derivative. F prime of s is going to be 2 cosine s. Now this guy right here, you need to apply the formula cosine u prime is going to be negative u prime times sine u, right? Chain rule. So u in this situation is 2s, right? So 2s prime is going to be 2, right? So it's going to be negative 2 times sine of 2s, right? Now don't forget the negative side right here, so it becomes positive, right? So you need to let f prime of s equals 0 to find critical numbers, right? You know that sine 2s equals 2 sine s cosine s, right? So it could be 2 cosine s plus 2 sine s cosine s equals 0, right? And 2 right here, it becomes 4, right? Alright, now I'm gonna factor 2 cosine s out. So it could be 1 plus 2 sine s equals 0, right? Now this one is the 0 product, right? So each of these one should be equals 0, right? So I have 2 cosine s equals 0, then cosine s equals 0, and then s equals pi over 2 and 3 pi over 2, right? Look at the domain right here, 0 to 2 pi. Alright, 1 plus 2 sine s equals 0, then sine s equals negative 1/2, right? So s equals 7 pi over 6 and 11 pi over 6, right? Now you have the candidates. It's going to be 0 and 2 pi, right? So 0 go first. Next one should be what? Pi over 2. Next 3 pi over 2. Next 7 pi over 6. Next 11 pi over 6. And the last one 2 pi, right? Now you need to sketch a table. Substitute these values back into the original function right here. Alright, so we have sine of 0 equals 0, cosine of 0 equals 1, so it will be negative 1, right? Now pi over 2, sine of pi over 2 equals 1, so you have 2 times 1. Cosine of 2 times pi over 2, which means cosine of pi equals negative 1, and negative side right here becomes positive, right? So plus 1 is going to be 3, right? Now next, sine of 3 pi over 2 equals negative 1, right? So you have 2 times negative 1. Cosine of 2 times 3 pi over 2, it could be cosine of 3 pi, which is negative 1, and negative 1 right here becomes positive, right? So it could be negative 1. Alright, now the absolute maximum is 3 as s squared pi over 2, and the absolute minimum is negative 3.5 as s equals pi over 6 and 11 pi over 6, right? Now the graph for question A, B, C is right here, right? Now let's move on to example number 2. Find the minimum and maximum velocity and acceleration. Alright, a particle moves along a straight line with s of t equal this one for t within 0 and 3. Find the minimum and maximum velocity of the particles on the interval 0 and 3. Alright, now you need to take the first derivative of this one, right? So I have v of t equals s prime of t. It's going to be 4t cubed minus 12t squared plus 12t, right? Then in order to find the minimum and maximum velocity, you need to take the second derivative of this one or the first derivative of vt, right? So this guy turns out to be 12t squared minus 24t plus 12, right? Let the v prime of t equals 0 is the same thing as 12t squared minus 24t plus 12 equals 0, right? So I'm going to divide both sides by 12. It turns out to be t squared minus 2t plus 1 equals 0, right? So it's going to be a complete square, right? So it could be t minus 1 altogether square equals 0. So it's going to be t minus 1 equals to 0, right? And then t equals 1, right? This one is the first candidate, right? Now you have the second candidate right here, 0, and the third candidate is going to be 3, right? So you're going to sketch the table. Now substitute t equals 0 into the function v of t right here, right? It's going to be 0, right? Now t equals 1, it's going to be 4 minus 12 plus 12, it's going to be 4, right? And t equals 3, it's going to be 36, right? Alright, so you're going to say that the maximum velocity of the particle is 36 as t equals 3, right? And the minimum velocity of the particle is 0 at t equals 0, right? You can conclude this one, right? Exactly the same thing. Now, question B, the minimum and maximum acceleration of the particle, right? So you have the first derivative of velocity is the acceleration function, right? So I copy this one down over here. Now, in order to find the minimum and maximum, I need to take derivative of this one. So I have a prime of t equals 24t minus 24, right? I need to find critical number, right? So a prime of t equals 0, right? And then 24t minus 24 equals 0 and t equals 1, right? This one is the first candidate, and don't forget the second candidate and third candidate right here, right? So you're gonna scan the table, right? Substitute 0 for t into the function a of t, which is right here. It's gonna be 12, and then t for 1 is gonna be 0. T for 3 is gonna be 48. Now you can conclude that the maximum acceleration of the particles is 48 at t equals 3, right? And the minimum acceleration of the particle is 0 at t equals 1, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.